Well, John Lang here at Trina. It's been a very successful couple of years, and the company's expanding. It's moving to a more integrated business model. What do you see from a manufacturing cost point of view as a key issue? What are you trying to drive out as far as costs are concerned? Especially when, Trina, you're moving as well to higher efficiency cells. I don't want a lot of people kind of hide behind, well, we're lowering our cost per watt because we're just improving the cell efficiencies. That's kind of a hidden aspect here. I'll sort of ignore that bit and drive down some of the manufacturing issues that you have in trying to under margin pressures that everyone is now facing.
I think basically, from my point of view, I think the cost reduction maybe three aspects. First one is how you become more manufacturing efficiency will be higher. For example, the yield of your different process will be higher. But frankly speaking, personally, I feel that this aspect already pushed to a certain limit. So even you don't want to mention about efficiency, I think we have no choice. So I think the important thing that we need to more or less people are focused on the cell. I think the important thing is the module power. So we just you choose one. I think the important thing is the module power, whether you can move it up. So for the market become not only cost sensitive but also become selective for the higher efficiency modules. So I think this one for sure will be one of the key to move up the market opportunity, also drive down the cost. But this is the equipment forum. For sure, I would like to mention something about the equipment. So for what we know that now the equipment, from the list we see that mostly are still European suppliers. So equipment cost, just now the plantation is much higher than semiconductors. So it's for PV around 20%, but for semi, for others, normally around 15%. So there is a room for the equipment to further push down the cost. This is what we are looking for. So there is another aspect is the material, because the running cost mainly is still materials cost. So how to push down those material costs? I think also come to a point that the market push more pressure on the cost. So we need collaboration from the material suppliers, equipment suppliers with the manufacturer. Now it's not really that you expect the manufacturer itself to improve the efficiency. I can sell you still expensive equipment. But the equipment manufacturers, for the current technology, we must look at how we lower down the cost. But there is another, we mentioned back about the efficiency, the higher power. If you can go to a higher power, reduce the cost, so basically you still have opportunity to increase your equipment price. So I think this is the way that once you move higher to a higher power equipment, basically the yield will drop. But because of the power increase, so you have a room to work on to improve the yield again. So that means that more or less from my side, I feel the yield, efficiency, materials, and also the collaboration from the different parts.
Well, you mentioned some very interesting points there. In fact, Stuart, Suntech been pushing high efficiencies via Pluto technology, but I guess it would be interesting to ask you, maybe give some colour on the challenges that you faced in actually ramping up Pluto technology. I might be wrong, but I got the impression that it was taking much longer than you thought, and there was a lot of talk in the industry that it was because you're moving to complex processing and designs, but they were costing more, and obviously that wasn't the object of the exercise. So perhaps you could explain some of the challenges that you physically had in pushing to higher cells.
Yeah, sure. I think maybe I'll even broaden it out a little bit, because for those that aren't aware, I actually have a dual role. So I'm the CTO of Suntech. I'm also the Director of the Research Centre at the University of New South Wales, and we have a very strong collaboration between the two. So the Pluto technology came originally from the University of New South Wales. And over the last 30 years, the university has been quite successful in commercialising technologies, and so there's been 4 examples of such technologies coming from the university that have all gone into large-scale production. And all the technologies have had the same challenges, and that is the fact that if you're doing something innovatively different, you inevitably need some new equipment that doesn't currently exist off the shelf to help in the manufacturing. So, for example, the BP technology, that came also from the university. In that case, we needed new high-speed lasers that just didn't exist off the shelf. For the Pluto technology, again, there's some specialised equipment that isn't currently available off the shelf. And so I think one of the things that's very easy to underestimate in putting a new technology into commercial production is how long it will take to develop that new specialised equipment for that purpose of large-scale manufacturing. And it certainly happened that way with the BP technology. It was very slow to ramp that technology up. And with Pluto, we set up a pilot line. It worked very, very well. The technology proved itself in terms of performance, low cost, and incidentally, it's not a more expensive technology. It's lower cost in dollars per watt technology than our normal screen-printed technology. But the problem for us was ramping it up. We actually bought our own equipment company, Kuppler, because we saw it as a big challenge to develop the new equipment. And in hindsight, we may have been able to do it quite a bit quicker if we'd worked with companies like Centrotherm, Rothenbauer, Applied Materials, and had them develop the equipment for us. But our fear in doing that was that we had very important IP tied up with our new technology, and we didn't want that IP leaking out. And so to keep it all in-house, we decided to develop all the equipment ourselves as well, and we did that through the company Kuppler. Now, since that time, Kuppler has done extremely well and selling a lot of equipment all around the world. But it took a long time. It took a lot longer to develop the equipment and to get the bugs out of the equipment in terms of getting the throughput. So there's never been a problem with the Pluto technology. There's just been a problem with the new equipment we've been developing in the scaling up of the technology. Thankfully, those problems are now solved.
There's a couple of issues there. Obviously, Trina Solar believes that you should equipment suppliers and materials providers should just basically cut the costs, cost prices rather, and others basically that you're not doing enough to actually bring products to market, actual equipment to market that are really actually ready for volume production needs and requirements. Sometimes the equipment just simply isn't ready or even available. I'd like to open up to the floor if there are any issues raised so far, or if you simply want to ask any questions to our audience. Does anybody have any questions right now? I've got plenty more to cover in a very short time, but does anyone want to ask a question at the moment? No? Everyone's still suffering from... Oh, yeah.
Hey, Mark.
Hi.
Chris Case from Voltaics here. And I heard some comments about, as you said, Mark, the materials cost and the cost of the equipment. I don't actually look at the analogs between semiconductor equipment and the PV equipment quite so directly, because it's a process of 1,000 steps compared to a process of 10, 20, or 30 steps. So dividing up and allocating sort of the margins between equipment and materials can be misleading. And in fact, I think the materials suppliers are being unfairly punished or pressured onto some costs. But what I wanted to ask was about sort of the views, especially since there's some thin film people from Calixo here, between the custom equipment and the off-the-shelf equipment as it applies to developing new thin film production lines like SIGs things or analogs to SIGs, and there seems to be both kinds of players out there.
Would you comment to about this thing?
Yes, I mean, we've gone through the development of our own technology, as you pointed out. To be honest, it took us now roughly, we're now in the 6th, 7th year in developing our own technology and manufacturing it. And the first 3 or 4 years was really just learning. We haven't been able to have good uptimes of the equipment because of very high temperature, which we're using over 1,000 degrees Celsius. And only 1.5 years ago, 2 years ago, really the equipment was stable and we were able to produce in now a larger scale. And I think we might have been more successful in working from the beginning with one of the leading suppliers together, but it was exactly the same topic as Suntec. We didn't want to do that because of IP reasons. Now we have developed it, and I think we have now to think about how we are able to commercialize Calypso or the technology in the future, because now it works. But as I said earlier, now the question is what is a good way to get such a technology to the market? The advantage which we are having is that the technology is very, very cheap. The furnace we are having, including everything, costs way below 1 million euro, including for a 25 megawatt line. And that is because it's such an easy process. We have no vacuum, no pumps, no nothing. And I think now we are able with the over 10% efficiencies to get it into a large scale. But the question is, are there people and large companies out who are interested in doing something like that together with us? And we're working on that.
Does that help you answer your question, Chris?
Yeah, well, you know what the issue is. One takes a long time and costs less, and one goes faster but costs more. And thin film needed all the help it could get. So, from time. All right, thank you.